Linear inequations. This is the new chapter we are starting with this class. We have dealt with equations for many years. I'm sure you started learning about equations in fifth or sixth grade. An equation is a mathematical way to express that two quantities are equal. So when we say that two quantities are equal, there is a left hand side and a right hand side, and they are equal in magnitude. That's what it means. And mathematically, here are some examples that you must be familiar with. X plus 6 is equal to 5x. This is an equation which has a variable x. There is a left side of the equation, a right side of the equation, and the two sides are equal. They don't have to be all algebraic examples. Here is an example from geometry where an angle ABC is equal to 60 degrees. That is an equation as well. So an equation compares two quantities and says that the two quantities are equal, and the equality is indicated by this sign. And this is a concept you are familiar with. So what is an inequation? Inequation is a statement that two quantities are not equal to each other. So the inequation will indicate that one quantity is either less than or more than another quantity. Here are some examples of how an inequation is expressed in mathematics. This indicates that there is a number x and the number x is more than 7. It may be 7.1 or 7.01 or it may be 7.001. We do not know how much x is, but we know that it has to be more than 7. What does this tell us, and how is this different from the first example? X is greater than or equal to 7. And this means that x may be 7 as well. It may be 7 or more than 7. And another way of stating it in English is x is at least 7, which means that the minimum value x can take is 7. It can certainly be more than 7. This means that y is less than -5. And these are symbols that you are familiar with. The next example says that y plus 11 is less than or equal to -8. And this is another example where this is a quadratic expression, x square minus 3x plus 14, and that is greater than or equal to 0. Another way of saying this is to say x square minus 3x plus 14 is at least 0. And I'm writing these words so that when you encounter such words in word problems, you will know how to interpret them. We can visually understand inequations by looking at some of these examples. Now, you look at this simple example. On the simple balance are a weight of 1 kilogram and some bananas. Now, clearly, the bananas weigh more than 1 kilogram. So we can say that the weight of the bananas is greater than 1 kg. So you can see inequations in our daily lives. You have to look for them. So there are many situations where we are comparing two quantities and declaring that one is more than the other or one is less than the other. This is an example where we say the girl is taller than the boy. The girl is taller. And how can we express it as a mathematical inequation? We can say the girl's height is clearly greater than the boy's height. So this is an inequation as well. Remember, we are always comparing two things and declaring that one is more or less than the other? Don't we say one batsman has a higher average than another? One runner is faster than the other. One car has a better fuel efficiency than the other. A person has a higher salary than another. All of these are comparisons we make in our everyday lives and say that one is more or less than another quantity. Let's take a look at some inequations in everyday language. We use inequations in everyday conversations. Have you noticed them? Summer days in Bangalore are hot. Temperature in the daytime will be at least 33 degrees centigrade. So, how can you express it as a mathematical inequation? So, we can try and say temperature in Bangalore in the daytime, in summer, of course, so remember the words at least, it means that it may be 33 degrees or greater. That's what at least means. I like that shirt, but I cannot spend more than 1,200 on it. That is my limit. So I can say money I can spend on the shirt, it must be less than or equal to 1,200 because I cannot exceed it. She is at least 30 centimeters taller than him. So how do we express this? So like I said earlier, we can write it simply as girl's height is greater than the boy's height, but that does not capture all the information provided here. How do we use the fact that there is a 30 centimeters there? So what does it mean? It means even if you add 30 centimeters to the height of the boy, the girl is still taller. So at least 30 centimeter taller than the boy can be expressed in this way. And I want you to spend a minute looking at these examples and how and understand how you can interpret a statement like this and write it as an equation or an inequation. What is a linear inequation? That is the name of this chapter. A linear inequation is an expression which is linear and there is an inequality. So all of these examples are linear expressions. So x plus y is greater than 7. It's a linear expression and that is greater than 7. 3y minus 8 is less than minus 11. So all of these are examples of linear inequations. Of course, the first example has two variables and the second and the third examples have just one variable x, and the second example has y. So the only difference with the first example is that there are two variables x and y, but they are all linear inequations. How do we solve linear inequations algebraically? If you want to find a solution for a linear inequation, how do we do that? There are some important rules to remember while solving a linear inequation. So let's go through the rules one by one. This is the first rule. Adding the same number to both sides of an inequation does not change the sign of inequality. What does it mean? If you start with an inequation, x is greater than 3, and if 5 is added to both sides of the inequation, remember we have to add the same number to both sides. So I have added 5 to both sides of the inequation. So if x is greater than 3, it follows that x plus 5 is greater than 3 plus 5. So we can conclude that x plus 5 is greater than 8. Similarly, the second one is y is less than or equal to negative 7, and I'm adding 2 to both sides of the inequation, and that inequation becomes y plus 2 is less than or equal to negative 5. So you can add the same number to both sides of the inequation, and the inequality sign does not change. And the last one, 8 minus 2y is less than or equal to 11, and then I'm adding 4 to both sides of the inequation, and the inequality sign remains unchanged. So that is the first rule. You can add the same number to both sides and the inequation does not change. Similarly, subtracting the same number from both sides also does not change the inequality sign. This is the second rule. If x is greater than 3, then subtracting 2 from both sides does not change the inequality sign. It remains greater than. So we can conclude from this that x minus 2 is greater than 1. If y is less than or equal to negative 7, by subtracting 8 from both sides, we can conclude that y minus 8 is less than or equal to negative 15. So the inequality sign has not changed. In the third example, I am subtracting 6 from both sides. And what do we get? We get 2 minus 2y is less than or equal to 5. Again, the inequality sign has not changed. So adding the same number to both sides or subtracting the same number from both sides of an inequation does not change the sign of inequality. The third rule, multiplying both sides of an inequation by the same positive number does not change the sign of inequality. What does that mean? Here are some examples. Y plus 3 is greater than 7. That is the given inequation. To that, we multiply both sides by the number 7. So by multiplying both sides by 7, which is a positive number, we get 7y plus 21 is greater than, I'm sorry, there is a mistake here which I'll correct. This should be, this should be 7 here. We are multiplying both sides of the inequation by 7, which gives us the conclusion that 7y plus 21 is greater than 49 because we multiplied both sides of the inequation by 7. Here we have the inequation x is less than or equal to 9, and both sides of the equation have been multiplied by 5. 5 multiplied by x is less than 9 multiplied by 5. So both sides of the inequation are multiplied by 5 and the inequation does not change signs. The last example is where both sides of this inequation are multiplied by 4. So if 8 minus 2y is less than or equal to 11, then by multiplying 4 on both sides, the inequation becomes 32 minus 8y is less than or equal to 44. So this is how inequations can be. These are the rules we can use to simplify and solve an inequation. Now we come to an important concept. The same is true if the two sides of the inequation are divided by the same positive number. So you could divide both sides of the inequation by the same positive number. Let's take one of these and see what it means. Let's take this one. We have the inequation. We can divide both sides of the inequation by the same positive number, and the inequation does not change the sign of inequality. Here I have divided both sides of the inequation by the same positive number 4, or I could divide it by the same positive number square root of 2. It doesn't matter which positive number you take, the sign of the inequation does not change. So multiplication or division of both sides of an inequation by the same positive number does not change the sign of inequality. Now this is the next rule, and pay attention to this because this is a little different from what we have seen so far. Multiplying both sides of an inequation by the same negative number reverses the sign of inequality. Reverses. This is That's a printing mistake. I'm sorry about that. So what do we see here? We see that y plus 3 is greater than 7, and I'm multiplying both sides of the inequation by the same number, negative 7. So what happens when I multiply both sides of the inequation by a negative number? What was greater than here, you see this greater than, has become less than. It reverses the sign of inequality. Similarly, if x is less than or equal to 9, I'm multiplying both sides of the inequation by negative 5, and therefore negative 5x becomes greater than equal to negative 45. What was less than or equal to here has become greater than or equal to after multiplying both sides by a negative number. 8 minus 2y is less than 11. By multiplying both sides by negative 2, the inequation reverses the sign of inequality. The same is true if both sides of an inequation are divided by the same negative number. Let's see how that goes. Let's take this example. We start with this and we divide both sides of the inequation by the same negative number, and it reverses the inequality. So these are the rules that can be used to find a solution for an inequality. Now the next important concept before we start practice questions: replacement set and solution set. Consider a linear inequation with one variable x. The set of all values from which x can be chosen is called the replacement set. So this is the set of all possible values from which you have to pick the final solutions. The actual values of x selected from the replacement set which satisfy the inequation, that forms the solution set. So if you have a list of all possible values that you can choose from, and you are told that you have to pick a solution from that set of numbers, that becomes the replacement set. And a subset of numbers inside the replacement set which satisfy the given inequation forms the solution set. So you can say that the solution set is a subset of the replacement set. So this is illustrated with an example. Consider a linear inequation where x is less than or equal to 5 and x belongs to n. Now this is a belongs to symbol. You have to be familiar with it, and this indicates the set of natural numbers, and these are symbols that you should be familiar with because they are going to be used in questions. So when you have that, this is the replacement set. X belongs to n is the replacement set. It tells you that you can only pick natural numbers for your solution set. So what are the natural numbers? So natural numbers clearly are 1, 2, 3. So that is an infinite set of positive integers. But you have to pick numbers that satisfy this inequation. Therefore, the solution set becomes 1, 2, 3, 4, and 5. How can you pick 5? Because the inequation says x is less than or equal to 5. So 5 can be picked. So there are 5 solutions possible. X belongs to n is the replacement set, and 1, 2, 3, 4, and 5 is the solution set. Let's try and plot some of these inequations on a number line. Now this is the replacement set. So you have to pick solutions where x belongs to the set of natural numbers, and this is the inequation to be satisfied. So how do we make sure that both conditions are satisfied? Now remember, the set of natural numbers includes these numbers. But we are looking for numbers which are between -2 and 3. So which numbers do we pick from the set of natural numbers? The only numbers we can pick are this, this, and this. 1, 2, and 3. Those are the only 3 natural numbers which satisfy the given inequation. Next one. Now z or z is the set of integers. So you have from -infinity to all integers. So the replacement set has changed, but the given inequation has not changed. So how does your number line representation change because of this? Remember, now you can choose negative and positive integers. So the can you pick -2? You can, because it's got a less than or equal to here. So you start with -2, -1, 0, 1, 2, and 3. So these 6 dots represent the final solution on the number line. Now what does this mean? This means that x belongs to the set of real numbers, which means integers, positive and negative. It means rational numbers and irrational numbers. It includes everything. So how do we represent that on this number line? The inequation has not changed at all. So what has changed from each of these examples is the replacement set. So what was x belonging to n became x belonging to z and x belonging to the set of real numbers. And therefore, since the replacement set is changing, the representation on the number line also changes. So in this case, every number on the number line between -2 and 3 must be included. And that is not represented if I put dots like this. When I put dots like this, I am saying that the number between here is not included. That would be wrong. I have to include every number. I have to include I have to include 1, 1.5, 1.25, 1.35. Every one of these numbers will be included in this inequation. So that can only be represented with a straight line going from -2 to +3. And the solid dot here indicates that -2 is included. And the solid dot here also indicates that +3 is included. So you can now see how the replacement set and the inequation together determine the representation on the number line. Now the representation is given and we have to indicate the rule that this signifies. So you can see here that 3 is included and it's got all numbers, all real numbers greater than or equal to 3. So we can write this as, and in this here -2 is included and all numbers less than -2 are included. So I can write this as what about this? See the hollow dot here and the filled up or solid dot there. It means that you cannot include -2. So I have to write it a little differently. The less than sign here means that x cannot be equal to -2, but x can be equal to +2. So hence you see the sign here which is less than or equal to. But on this side you see only less than. So let's start with some practice questions. So multiplying both sides of the inequation by a positive number does not change the inequality sign. Remember the rule? So I will multiply both sides of the inequation by 2 and I will get this. 4 minus x is less than 6. I will add x to both sides of the inequation. Remember that rule. So what does that become? It becomes 4 is less than 6 plus x. And then I will subtract 6 from both sides, making it 4 minus 6 is less than 6 minus 6 plus x, which gives us -2 is less than x. Another way of saying this is x is greater than -2. And how do we represent this on a number line? We can say that we start with a 0 here, and if this is -1, -2, and then we have 1, 2, 3, etc. See that we have concluded that x should be greater than -2. And so we can start with a hollow dot here and then write an arrow in that direction indicating that it can take all real numbers greater than -2. Make sure it's a hollow dot because it indicates that -2 cannot be included. Our next question is this. We multiply both sides of the inequation by +6. So we get 6 multiplied by which means that So we are using every one of the rules that I discussed earlier to simplify this. First, I multiplied both sides of the inequation by 12, by 6, I'm sorry, so that I can get rid of these denominators. 6 happens to be the LCM of 3 and 2. So we get 4 minus 9 multiplied 9 minus 6x is greater than or equal to 12, and so x is greater than or equal to 17 by 6. And how do we represent this on the number line? 17 by 6 is a number between 3 and 4. You see, this is a number between 3 and 4. So essentially x is greater than, or it's not between 3 and 4, it's between 2 and 3. My apologies. It's between 2 and 3. It's 2, 5 by 6. It's very close to 3. So this can be represented as follows. So if I have a 0 here, remember I can choose my own scale. This is my number line. So 2 and 5 by 6 may be a number somewhere here. All numbers greater than that number, greater than or equal to that number, will be valid, or will be the solution set of this inequation. Remember, we have applied all the rules we discussed earlier to simplify this. Our next question is this. So I can bring the minus x by 9 term to this side. I multiply both sides of the inequation by 9 to get rid of the denominator. So we get 6x plus x is greater than 42, and so 7x is greater than 42, x is greater than 6. And how do we represent this on the number line? If you have a number line like this, it can be greater than 6. So I have to put a hollow dot here, remember, because x is greater than 6, and then an arrow indicating that all real numbers greater than 6 are part of the solution set. You must pause these videos and try these questions by yourselves, and then look at my solution. So here there are two inequations. So there is one inequation here and one inequation here, and we have to find the values of x that satisfy both inequations. So let's see how that's possible. Let's take the first one. So we have minus 8x minus 13 is less than or equal to 27. So minus 8x is less than or equal to 40. If I divide both sides of the inequation by negative 8, then the inequation changes sign and becomes like that. So we have x is greater than or equal to negative 5. This is the solution set for the first inequation. So what about the second one? X is less than, and this is the second one. Let's see what that leads us to. So one says x has to be greater than or equal to negative 5, and the other says x has to be less than or equal to negative 5. So what are the values of x that satisfy both inequations? There's only one value, and that is x equal to 5. Because x equal to 5 satisfies this inequation as well as this one. So how do we represent this on the number line? So if you have a 0, a minus 1, so the only value that satisfies the inequation is x equal to negative 5. Because there are two inequations and we need to find a solution that satisfies both. Let's look at something slightly different. How do you represent the following situations as inequations? In the first three math tests of the year, Sohail scored 21, 24, and 19. There is just one more test to go. Sohail must average 23 in the four tests to pass. So if S is the minimum score he needs in the final test, how can we represent this whole thing as an inequation? So if Sohail scores S in the final test, remember the average must be at least uh, 23. It means that the average is 21, the first score, 24, the second, 19 is the third, and he got S in the fourth, and the average of these must be greater than or equal to 23. This is our inequation. So we can say that it's 4563 plus S is greater than or equal to 92. And finally, you can say S is greater than or equal to 92 minus 63. So if Sohail scores at least 29 in the final score, in the final test, then his average will be at least 23. So this is how this question can be done. I think I made a mistake in the addition here. It's 45 plus 19 is 64, and this should be 92 minus 64, resulting in a minimum score that he needs of 28. So this is how the statement can be converted into an inequation. So now he can figure out what is the minimum score he needs in the final test. Okay, next one is this. How can we represent this as an inequation? I've started a taxi ride. The first kilometer is 27 rupees and every kilometer after that is 18 rupees. I have only 300 rupees for the trip. What is the maximum distance I can travel? Well, remember the first kilometer in the taxi costs 27 rupees and every other kilometer after that, every other kilometer after the first kilometer costs 18 rupees. So if I travel d kilometers, then how much should I pay? I should pay 27 for the first kilometer. And how many kilometers are left now? After I have paid 27 for the first kilometer, I have d minus 1 kilometers to travel. And for each kilometer of that, I have to pay 18 rupees. And the total cannot exceed 300. So this becomes my inequation. So 27 plus 18d minus 18. From this we can say 18d is less than or equal to 291. So this is how you can take situations like this and represent them as an inequation. And these are good practice questions to try, because it is one thing to solve an algebraic inequation using the rules, but it is also a necessary skill to be able to look at a situation like this and represent it as a mathematical inequation. So now let's do a quick summary of what we have discussed so far in this class. I gave you several examples of inequations in our everyday lives. So we are comparing quantities all the time. We may be comparing speeds of two people, batting averages, salaries, marks, prices. There are all kinds of things we are constantly comparing and concluding that one quantity is greater than or less than another quantity. A mathematical expression of that is a linear inequation. So let's see what linear inequations are. Inequation is a declaration or a mathematical statement that the left hand side is not equal to the right hand side. So there are four symbols that indicate that. This means more than, one quantity is more than the other. This means that one quantity is less than the other. This means that it is greater than or equal to. And this finally means less than or equal. So these are the four symbols that are normally used to represent inequations. So a linear inequation is one where the algebraic expressions are linear. So you must remember what linear expressions are. The highest power of all the variables will be 1. So these are linear inequations. What are the rules we can use to solve linear inequations algebraically? We saw that adding the same number to both sides of the inequation does not change the sign of the inequality. What does that mean? If I have an inequation y is greater than or equal to 7, I can add the same number, let's say 2, to both sides, and the inequation does not change the sign. This is an example of the excuse me, first rule. What about the second rule that you can use to find solutions for the inequations? Second rule says that subtracting the same number. So let's take the same example, y is greater than or equal to 7. If I subtract minus root 3 on both sides, the inequation does not change. I am subtracting the same number from both sides. Now it doesn't matter what number I subtract as long as it is some real number. The inequation does not change the sign. The third rule says that multiplying both sides of an inequation by the same positive number does not change the sign of inequality. What does that mean? It means that if y is greater than or equal to 7, and if I multiply both sides of the inequation by, let's say, a positive number 3, then it becomes 3y is greater than or equal to 21. I chose to multiply both sides of the inequation by 3. I could also divide both sides of the inequation by the same positive number, and the inequation doesn't change. Here I've divided both sides by 9. And the last rule is multiplying or dividing both sides of an inequation by the same negative number reverses the sign. So what does that mean? If you start with the inequation y is greater than or equal to 7, if I multiply both sides of the inequation by negative 2, then it becomes minus 2y less than or equal to negative 14. What was greater than or equal to here has become less than or equal to when we multiplied both sides by negative 2. And it is the same when I divide both sides by the same negative number. So these are the four rules that we used to solve the inequations. And finally, we learnt about the replacement set, which is the set of all possible numbers from which we can choose the solution. And then we learnt about the solution set. These are the actual values selected from the replacement set which satisfy the given inequation. We saw an example of that. When we write something like this, that is a replacement set. It indicates that x has to be a natural number. And then when I go on and say something like this, or let me choose a different example. When I give a replacement set as natural numbers and an inequation like this, then the solution set becomes the actual values that satisfy the given inequation. And those numbers are selected from the replacement set. And this becomes, we saw what replacement and solution sets are and how they can be represented on the number line. So this is what we studied. In the next class, we will take a look at uh, more difficult, challenging questions in algebraic inequations, linear inequations, and see how they can be solved. Thank you for watching. I will catch you in the next class. Bye.